a sec. Where it's gone? Yeah, how's it going?
So there was a new model came out. GPT-5 Codex.
I've seen good reviews of that so far.
So far, so good, right? So where are we? Open AI news. What? What? No. 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 This one. Oh, this is interesting. I'll bring that up too. Oh, whoa! Stargate UK. Mate, you guys are about to get fucking lit. Right. So, GPT-5 Codex. Marginal increase in the software bench. These long run tasks, like that's quite a big jump.
That's pretty good. Yeah.
So that one of these examples was changing 232 files and 3,541 lines to refactor a variable through all of the logic, right? So that's a pretty ballsy task. But the biggest win is this graph. You can stop me if you've seen all these graphs, though. I don't want to go over
No, I haven't seen
something.
these graphs yet.
No,
No,
okay.
just
So this what you can if the what is that mauve? This thing, this color, the light color, is using their internal coding traffic based on GPT-5 in the times when the lowest amount of tokens were returned. Codex returns much lower. But in the times when the biggest amount of tokens were returned from GPT-5, Codex doubles it. So it's like 10% of the traffic when it knows that it's really not something it should spend a lot of time or effort on. And then it comes up and toggles.
So it's throttling.
Well, it's able to amplify correctly. Like it knows when it should be not doing anything, but then when it needs to, it can amplify up to double the token rate, double the amount of tokens to get the job done. So it has very good task appropriate effort.
Yeah.
So that was cool. That's massive. Like incorrect comments in a PR, like 4% is like even a human couldn't pull off that.
Yeah. We're beyond humans at the moment.
Yeah. So anyway, I got that going. I might as well just I'll show you what I got. I don't know if you had time to see the video I sent through.
No, I didn't. Sorry. Yeah.
Mate, what have you been doing?
I'll tell you later.
Okay. Right. So the demo, with maybe a little ado. Right. Now we're currently on GPT-5 because Codex is not available in the API, and we're on low reasoning effort because I can't be bothered waiting. So, the status, we are in Codex version 36, which is the latest one. Interestingly, like the day before Codex came out, that's when I messaged her and was like, dude, there's a new model landing because they changed the Codex source code to include these extra model selections before it even got announced.
Yeah.
So, I don't know what that's worth. A day or so, whatever.
I've been doing a bit of. I should write this down and send it over. I've been doing a bit of prompt engineering on how to get the best out of 5, and there are distinct things that you can flag to get it to perform at a far higher level.
Right. Okay.
I'll the written notes at the moment. I'll send them over.
Yeah. Um. There's a really interesting patch that. Oh, excuse me. Golly gosh. A really interesting patch went into. Oh, where was it? Where was it? I don't know if I can search for it. That is going to be too much to search. There was a patch where they patched the system prompt default for codecs to add some additional settings for GPT-5 codecs. So that was here we go. There, update SwiftFox prompt. So these were they codenamed it SwiftFox. Who the fuck knows? I mean, whatever. But this was the patch that they made to the sys prompt.
Revert existing changes you do not make unless explicitly requested.
Oh, that's just formatting, that is.
Okay.
This extra line that they added, wiping out if the user makes a simple request. So I assume what that was them trying to stop GPT-5 working too hard for simple questions.
That's the throttling thing.
Yeah.
Throttling's not the right word, but you know what I mean.
Yeah,
it's
yeah.
Like,
yeah.
Try harder when it's hard.
Well, they wiped out "you must try hard to complete the task," so they're like,
right.
"That's
so
that's right."
That makes all sorts of sense because if you say try hard, it's going to try hard.
Do not waste time on actions. It's like, well, they've kind of baked that into the model now, so it doesn't even matter.
Yeah, no. Utter sense.
And then this thing. So yeah. Anyway, if you take a look at that prompt thing, you know that I just found it interesting that those were the changes that they themselves made to the model. But what's been quite interesting is that like all the heat seems to be on the CLI, and I can't even remember how it was that I started looking at the CLI. And then remember I rang you and I was like, "Oh, dude, this thing."
Man, that's all I've been asking for. CLI.
Yeah, I know. Let's not dig into that. But all their effort seems to be on CLI, like massively. And you know they've got the VS Code extension. They've got the here I'll show you even.
I can give my theory about why and why I was so keen on CLI. If the CLI is the heavy lifting, and given the on the fly coding, getting a pretty front to it it's not trivial, but it is a lot less than the heavy lifting. So you concentrate on the CLI first.
Yeah, but it wasn't. That's true what you say, but it wasn't always the way. Like they've only recently converged on CLI as the thing, right? But now they've just exploded with Codex Cloud, Codex IDE, Codex CLI. They basically kind of in a lot of ways screw Cursor with Cursor's agent integrations, and basically their IDE replaces what Cursor does. Cursor right now only has of benefit to you is, see, it looks like Cursor's little chat in the sidebar, but now it's like OpenAI's version. So Cursor has the autocomplete thing in the terminal, in the editor, but that's about it. You know, it's kind of unfriendly. Like this was not friendly to Codex, to Cursor.
Well, Codex is tier 3, and so it's always going to get wiped out.
Cursor, you mean?
Yeah.
Yeah.
Cursor.
Yeah. So I don't know why, but it's all converging on CLI, and you know where sitting sort of, we're cursed with being just a little bit early. Like we're in the game and we know where the playing field is. We're just like, So anyway, without further ado, this is where we're at. Now, here is what I can do for you. Start 2 codex faces on yourself. Ask the first one what the weather is in Edinburgh, and ask the other for a bangin' Rogan Josh recipe. Hang on. Before you call the interactions, make sure you print out the UI. The views of. Now, I'm not sure if that's going to give us, because I wanted to see the URLs before they came out, so I'm not sure if that's going to work, but whatever. Anyway, with some ado, okay, we listed the faces. We got the available kinds. We've got the system face. We've got the test face. We've got the inspector face. And somewhere deep in there is the codex face. The plan has been laid. Create 2 codex faces. Create face codex. Create face done. Create face codex. Create face done. Read face, read face. Okay, we got the 2 faces. Oh, there's the URLs. Alrighty. So this one is, thank you. You followed instructions. You good thing. So we'll go. So this is the other terminal. The face and what was the other thing? O2. Okay, so that one. O2. People, what are we doing? What are we doing? What are you doing? Oh, you're waiting for me. Shit. Garbage. That was nice of it. Okay, so now you'll see face 1. In came what's the weather right now in Edinburgh, Scotland, include temp conditions, blah, 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 blah. Phase 2, give me a bangin' lamb Morgan Josh recipe for 4. Don't know why it needed to be 4. Bullet the ingredients and US measures, then concise steps, include cook time and key tips. All right, that's a bit more than I needed, but whatever. So we're sitting back here. We've done a web search out. The internet has gone. And now we're waiting, and we're waiting, and we're waiting. That completed that one. Ooh, tasty. Okay, here we go. Phase 2, weather. Edinburgh now, 12 degrees Celsius, cloudy, wind precipitation, not listed in my feed. Well, it's not that useful, but whatever.
It's not really.
Phase 3, recipe, interaction, ingredients, steps, cook time, and tips, return, see face view.
Okay.
This,
that is awesome.
That's the thing.
That's nice.
The trouble is, Maxwell, that I look at this and I'm not seeing an empire. So
You're not seeing any what? Sorry.
I'm not seeing an empire.
An empire. I don't know what you mean by that.
Well, it's all well and good what it just did. It ticks the boxes for what we've been talking about. How do we go from here to world domination?
Ah, the whole world domination thing. Okay. Well, first slouch your underpants. Stuff happens and then profit. Um, we can use this to just by ourselves to generate cash. Now, the question really comes in if we were to release this, would this give additional benefit over what other tools are out there?
Yeah, I guess that's the big question, right? And would it give it that benefit to us? I think so.
I believe so because what we got is a real stripped down, fast version of exactly what we need in order to do like translations and OSINT and so on.
Yeah.
And that's what we're being asked for. And it's like, okay, that's great.
Yep.
Send a quick prompt to each face asking. Right, so this face is talking to two other faces, asking it for the capabilities of each face.
Yeah, but what I wanted to show you was see how it's the same model with the same prompt and the same data, but it's slightly different. And so you can imagine that if you ran it across like 20 faces, this is that the jitter or the variance of each response, where
Yep.
you'd be able to assess good variance, bad variance, convergence is here, like this is the ability to run concurrent model calls for the same thing and then look at the responses back and then make a choice.
Yeah.
And it becomes super apparent, even when you just see two in a row, like same but different. So
Right. Yeah. And how would you write that recipe to disk? You just created a recipe. I'd like to save that. Thank you very much.
Yeah, okay. I can either save the response that came back to disk, or I can tell the Rogan Josh guy to save that to disk in
Nice.
a .md file. Please, thanks. And now, Rogan Josh guy was this guy. Please save your full lamb Rogan Josh recipe just produced into a markdown file at recipe/roganjosh.md in the workspace root.
Okay. Creating markdown file and folder, then writing in the recipe content.
Now I made some hotkeys for you. No, I didn't make some hotkeys for you. Sorry. Saved.
Right. Where is that saved?
In the working directory.
Of which face?
Because they're all on the same agent, it's the same for all.
Right. Okay. All right. So you now stashed that Rogan Josh.
Yeah.
So you could say something like
list the files in the current working directory, please, and give a quick summary on each.
Yep. Yep.
GPT-5, by the way, so Codex is, better, but it's sort of, I feel like the S curve is, I can handle this.
Yeah. And if you say, tell me where the Rogan thing is. Yeah. Yeah.
Oh.
So it's in headers recipes.
Because the current working directory is /headers, but it's been saved in /workspace recipes Rogan Josh.
Oh, why does it want to copy it into headers?
It seems to be part of the programming is it always just suggests something that I might want to do next, so that I can just go yep.
So if you say no, just show me the file.
Well,
and there it is. Brilliant.
Good. So, is that nap to nap communication?
That is nap to nap communication.
Okay, good. So
nice. That's nice.
Next year, I'll give you the next thing you asked for. No, so that, yeah. So, I mean, all I'm saying is that is the thing that we've been chasing. But now what? Like, I'm like, okay, that's cool. We can do anything. But what? Like, what now? And I guess more practically, what are you missing? Like, what am I to do next? Because I have a bunch of things to do next in terms of tidy ups here and there and code rework, but my problem is it the right thing to do? Because it's really needs to be in collaboration with you, because I'm a little lost. There's an awkward decision coming up. Well, a bunch of them. The awkward decision is, do I push on with the ugly cobbled together integration stuff that I've got to deliver a couple of key features to you that you really need? Or do I hover for a bit and clean up and modularize, harden before making a push for the next feature set? And what is that feature set to be?
How do I get my hands on this?
You go to that URL there, which is the same one I've been pushing at you for a while now.
Right, so Universal Compute Fly Dev. And then am I going to be generating a whole bunch of docs over your shits, or is that a separate?
This is a completely disposable situation here, so you can go for your life on it. What I was going to do is split the cloud environments so that I'll produce a stable one, which I test it and then I set it up there, and I don't touch it until I've tested again, and like a bleeding edge one where I'm sort of cavalier, shall we say, with how things get published. Now that I speak to you, I realize that I need to add auth pretty quickly, because you want your own computer at this moment, right?
Yeah, right.
Okay, yeah. And one of the things that it hasn't been tested for is creating a new agent and then calling the faces on it. But the math all kind of works. Like, it's the principle works and the code works. It's just DNS, internal DNS hasn't been, I haven't put that in yet. So remember I told you how to name an agent in a parent-child relationship, where it's like agent -- parent -- grandparent dot fucking whatever dot computer or something like that. So I haven't done that bit.
Yeah, no, that's fine for now.
I'm just trying to call out things that I know have to be done. I'm looking for upvotes on which ones are the thing to do.
How would I, in this, upload a file of, another
upload a file? Upload a file. Well, that is a reasonable thing to ask for. So I cannot do that right now, but I can, first of all, make a note to tell you or signal to you that I am intending to do that. So you could, if it was text, you could paste the content in here. Like you can go like that and then go paste.
Yeah.
But that's not really what you mean, is it?
No, because that's just sticking in the prompt.
I know. Okay,
yeah,
so hang on. Yes, I know. Oh, there was a Control C. There you go. Okay, now I want you to cd into the workspace directory and then clone a fresh copy of the Dreamcatcher dash tech repo on org repo on GitHub that has the reasoning stuff in it. Fun, right?
Can you give it a URL saying, I want you to download this PDF?
Yeah, so you could shell out, you could exit out of this and use like git clone blah 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 blah. And then start Codex up again and then carry on. So you could do that.
Yeah, okay. That'll be a workaround. So I could, if I wanted to, access the repo. How do I find the repo that is saving this to?
Well, yeah, the README. How do you open the repo? What do you mean? Sorry.
Say I've got a URL of a PDF that I want to make available to this CLI.
Like how do you download from a URL?
Yeah.
Do you know? I want to test something. Find any PDF online and then download that PDF into this folder. You should be able to do that. You can also shell out and just use like curl or wget or any of the Linux commands. Download a dummy PDF into headers. Okay. So that's it knows how to do a surprising amount. Put it that way.
Right. I'm just thinking though. Right. So my workflow say would be I would take these 5 files as context. Don't really want to cut and paste them. Here are these 5 files, and here's what I want to do with them. So
yeah. Well, what kind of files are they? Are they text?
It could be text, could be images, could be
so you'll need to give it some hints, and you might need to build some quick tooling if it has images. This current model can process images and interpret them, but it's a little bit shaky, and also I don't really know how to do it. PDFs, it'll probably figure something out, but the chance of it getting it wrong goes up because it will need to use tooling. That's not a direct task. It can't read the PDF raw, but it can use tools or ask for tools or install tools. So you can install any of the Linux packages that are used for doing anything, and this thing knows how to, install them. I can say, can you install the Nmap tools? So this should call out to a Linux package manager. Yeah, there we go. apt-get update. Yep. apt-get install. Yep. it's probably gonna work. It's pretty powerful, eh? Like,
That's not bad. That's I could work with this. And so the big thing is, I guess, where is the repo? Is it on GitHub?
what repo?
When it's saved that Rogan Josh.
Oh yeah. So tragically, now scan thine own self. Tragically, nothing in this model uses anything that I have built before. It uses all of the knowledge that I picked up along the way, but none of the code. So right now, there is no Git repo. I was just going to use GitHub for now. It is obvious to me that this system, to be efficient and fast, and also private and yada yada, needs to have a file system layer that emulates a Git working directory, and also basically does what Artifact used to do by virtualizing the repo. But right now I don't have that because we're exercising the does this pattern even work bit. That's fun.
So
that's pretty good.
The reason I'm asking that is I'd like to do some work on this where the end results are persistent.
Yeah, so okay. Your initial issues. When you're working on these computers, when you're working on these Docker containers for now, if they crash and need to be restarted, you will lose whatever files you had saved. However, what I think our workflow will be for now is to fire up the agent, clone down some Git repos or a Git repo, work on the files in the working in the repo working tree, work directory, and then commit and push back to GitHub, and that's the permanence. Yeah. Does that work for now?
That works for now.
Okay, so the question, well, it is available because I just cloned a repo right now. So like,
so if I create a GitHub repo and then say clone this repo down into your working space.
Yep, it'll pull it down. It just did.
Pull it down.
Yeah. So like and right now, I just pulled down.
That works. That's good enough.
So this is the Jest AI thing, right? And this is see, that's like git remote dash v. See, that's when I did that task further up, that pulled down from Dreamcatcher Tech Jest AI. It pulled down the repo and cloned it to disk. So you can either.
So this is my your buffer.
Well, yeah, your buffer. That's right.
Right.
And
no, I'm happy with that.
All that was going to happen once I get the fancy bits up is that your clones will be near instant, and it won't take up any local disk space. And additionally, the mutations that you've made may optionally be shared with other agents, because right now you can't share the mutated state of your working directory. You have to commit it and then push it and then they pull it. Yeah. But once I get the fancy bits in, you could share the mutation if you wanted to. So
right. Okay. So say here's our workflow that is in hand.
Yeah.
I could try that today. Got a whole bunch of accounts information for this pharmacy business. I can create GitHub repo,
Mm-hmm.
stick that in.
Making sure it's private. Yep.
Yep. Then go to Universal Compute and say, right, pull down this repo at this URL.
Yeah, you could, but don't do that here because there is no auth on this system. So private data is available to all on the internet. So don't.
Oh, right. Okay. Right.
Yeah,
Fair enough.
don't.
Yeah.
This is treat this like a security-less prototype system. I am simply presenting this to you to say, have I got the bones of this right? I'm about to bake down auth.
Right. So once auth is in, that previous flow still stands. I've got a repo that others can look at.
Yep.
I can add files in directly. I can then come in here and say, right, I put a bunch of files in this folder. I want you to consider these, and this is the question you need to ask.
Correct.
Right. Once auth is in, then that is Balzer.
But you can also do some fancy shit. Like you can say, for each one of these files, I want you to create a new codex face, and then I want you to ask each one to do this job.
Right. Right. On the codex faces, can the codex face respond back? So you create codex faces.
Like this one over here.
Yeah. Can you talk to this and get it to talk back to the parent face?
That's not in there now, but that's pretty easy to add. So face talking to face, it did not make. Hang on. I might actually be able to do that now. /mcp interactions, create an interaction with face. Hang on. List all faces. Create an interaction with face. Yep. Where did my text go? That's weird. Okay, create an interaction with face -1, asking it who its daddy is. Oh shit. Codex. Who's your daddy? I pushed into there because it landed just as because I canceled codex, it just dropped the text in and pressed enter, but I had to start codex for that to work.
All right.
You have prompting work to do. This thing doesn't always do what it's supposed to do.
That's all right. I've been working on the prompting.
Input, who's your daddy? Reply, face for URLs, proceeding to ask each face its question. What? I don't know why that was bung, but you did see that it did actually talk back to the face that made it.
It did, yeah.
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 So the question I got for you is that right now we got this concept of faces and we got this concept of agents. And I sort of don't like it because it's tempting to say, sitting on this agent here, which is just one agent, that I'd like to spin up 20 faces.
Mm-hmm.
That, as I found out the hard way, will crash the system due to exhausting the RAM on the computer, which puts us into the most horrible of computing problems, resource constraints.
Mm-hmm.
And so, how I'd really like it to go is that you only really have one AI face per agent, and then you make a new agent. And it used to be in my head that having multiple faces on the one agent was useful because you might need to share the working directory or the mutable files. You might need to be sort of working together on a mutating thing before you chose to do a commit.
Mm-hmm.
But if I put in the fancy bits where that mutating file system is actually presented as a network drive, so it doesn't really belong to any one agent, it belongs to the, let's call it, artifact service, then having one agent per AI face achieves the same thing if they're all pointing at the same mutable working directory.
Mm-hmm.
And so that's really what I'm asking you. Or it's like I in that agent file, the agent package.toml thing, we'd sort of talked about that package as being how you configure an agent, and then being able to say that you want multiple other faces to occur within the agent. And I think that is subtly wrong, because I think that what defines an agent is the Docker container, the Docker file. So the Docker file has all the shit in it, like oh dear, where is my thing? In the Docker file, it's like install curl, wget, DNS tools, git, install JQ, less, like what operating system are we on? What version? Okay, everything's done. Install codecs. All right, ready, steady, go. And then the face is really the stuff about an agent that I care about. Like, oh dear. This is that TOML file. All of these things are really pertaining to just one face. So they'd say what Docker file they require, or a range of them.
Mm-hmm.
And then after that, they'd have like, here's my model. Here's my configuration for the model. Here's my sysprompt. And then you'd be like, here's my tools that I have. Here's the MCP tools that I want to be given. And so I used to think that we had to be able to configure multiple faces in the one file, but I think that that's wrong. You should make one agent package and intend to run only that on the agent. I can technically make it possible to run multiple faces on the same Docker container, but really the point is, first of all, why? Second of all, if that mutable directory is shared between agents, if it's independent of what the agent is, then the agent in a way becomes that face, and so the face concept is really more about the views. So we should really sort of say, well, an agent package represents the AI element that runs on the Docker container, and these faces that you can add are like extra services that are going to start, like a pretty web UI, a dashboard, a blank terminal session, or there are other ways that while the AI face is running, it can flick out these extra ports and things that you might want to interact with, or other agents might want to interact with. And that's kind of the thing that's really bugging me, right? Is like that config file. There's faces and there's agents. I kind of want to say that the AI agent is special. And I know I'd sort of tried to say that really the computing platform, like if we call the container the Coco, the agent is what you run on top of it to be agentic. You could still use a Coco controlled by an agent using traditional I/O levers. Like you can still run arbitrary code and packages, but the crux of the system is the AI element. And I'm sorry that I downplayed that. The mechanics of being able to support non-AI agents must be there, but I think in terms of thinking about the system, the if you don't think about it as AI centric, it gets quite messy, because you're like, well, what am I doing? I just have a Docker container. Why have I even named it something different?
So the agents can share a repo or access to a repo, and therefore they have a shared working space.
Well, more than just a repo, they can share the folder that the repo is checked out into. Because the way I'm going to present these fancy bits is using NFS. So it's just a network file system that each running Coco has got access to, and when it runs its agent with the faces, they all look at that and they think that's their working directory. So we kind of, that's what they think they're working in, and it's shared by all these other simultaneous agents.
That does make sense. Yeah, that does make sense. So
and if I do that, it means that I can dump the problem of resource management out the fucking window. Because otherwise, how many faces can you run on a Coco? Well, now you're tempted to spec a bigger Coco. But what if I spec'd it and now I've stuck with it, and then I'm halfway through a job and I need like another 10 agents and I just don't have the headroom? And so it gets quite stupid like that. But if it was one container per agent, and it was cheap and cheerful to spin them up and they could share the same file system, then you should just have one Coco, because a Coco represents a CPU, or at least a virtual CPU, and some RAM. And you don't have to worry about that. It's like, this Coco is spec'd for this face size. Like, it is tested to run this particular program without incident. And so the only
makes sense. So you have as many as you want.
As many as you want, and you don't even have to think about it. You're not resource constrained. Like, you might argue, yeah, you could pack a bit more in if you didn't spin up a whole Docker container per thing, but then you're like, yeah, but then you've got that accursed phase change where at some point you hit the edge of the tin. And my preferred place to hit the edge of the tin is never, or at boot. I'm like, no,
because it sucks to like have anything crash because of resource.
It's so complicated to manage it, to schedule, to plan for it, to detect it, to fail over when you got it. It's like, what if your freaking Coco crashes and it's got 100 faces on it, and you're like, oh dear.
So the whole point of having multiple faces was to allow for collaboration on the same thing.
Yeah, yeah, it was, and I think that led me astray because that's being suckered into the early constraints of the system because we don't have the artifact layer which presents you this network file system that is the working directory.
Yeah, yeah, but if you've got working directory and yeah, it's like a inside of an office, you've got a common file system. It's like,
Yeah,
hey, yeah, check
yeah.
out working on this, or you know, I'm going to commit this.
Yeah, the file server. Everyone in an office is used to the file server, and that's kind of, I guess, now that you say it that way, using the model of people working together, a business, hardly anyone works on their local machine. They all work on the networked file system, right? Immediately. Like
Yeah,
they check in, they check out, they do all this stuff, right?
yeah. Um, no, I agree. Are we losing anything?
I think we're
Um,
gaining something there because it really comes down to that core file system, and you've just given me an idea. Like, it. This is why I value talking to you because, man, these things we're talking about now, they seem like obvious priorities now that you're there being like, how do I get something done? And I'm like, oh well, actually this other thing. And so my priorities are much clearer. But the idea that I think I can do very cheaply is actually set up a legitimate NFS server, obviously a tiny one, but
mhm.
the NFS server will be the thing that mimics what the full-blown artifact piece will do, but that will provide you with permanent storage that survives reboots, and it is your working directory, and it's a checked out repo of somewhere on GitHub. And then
Yep.
your agents can be ephemeral, and you can have as many of them, but I can make them one face per agent. How does that sound?
Yes. Yeah. Yeah.
And in that way, that's really close to the model without doing anything fancy, just using off-the-shelf cobbledy bits, running an NFS server, and then you're like, that represents artifact, which is it's kind of like that's what defines the agentic computer is the file system. It's one file system boundary. That's what makes it a unit, a thing. And then
Yeah.
the agents don't have any long-term storage. It's the computer that provides the long-term storage.
Yeah. Yeah.
Yeah.
Absolutely. And I'm quite comfortable with the idea of um, effectively checking out a file, or it's like I'm working on this,
Yeah.
uh, and yeah, sure. If I were to lose the session, I'd lose some work. Well, that's the same as you're losing your buffer. You haven't saved it.
Yeah.
Oops.
Yeah. Well,
Um,
yeah, but because the agent would be saving to NFS, and the NFS would be long-term stable, you wouldn't really have lost much at all. And then it becomes like my job is to persist the agent state somewhere within the NFS so that
right.
when
So
you if there's a fault, you can recover, you can destroy the container that holds the agent, but you can fully restore it with fidelity if you have this NFS storage.
right now, a couple things. So I'm working more laptop. My laptop dies.
Mm-hmm.
Sadness. I recharge and then get back on. Can I get
Mm-hmm.
back my previous state?
You're asking right now or with the NFS
with it
intermediate?
with this with this model.
This
Sorry,
model,
with this.
this model right now, if your laptop dies, yeah, you can, because you'll just start up your browser again, possibly on a different computer. You'll come in and it's all exactly how you left it. Now,
Right,
what I mean by
right.
that, and this I should show you this just so you don't get surprised by it, is that if I open this same tab again, and I go, hey, see, it's the same, like anyone on the internet, including you, can browse to this location and you'll see what I see,
Uh-huh. Why
right?
is the URL lacking any specificity?
What?
I'd expect it.
This
Uh,
URL
yeah, there seems to be.
lacking?
What am I
What do you,
seeing here?
what do you,
How do I, if I were to want to share a URL with you about a specific agent and the state of it?
yeah, yeah. So at the moment, um, there's only one agent and this is its URL. But
Right.
as soon as I turn on the multi-agent feature, which I am able to work on now because we have agreed that faces can be one per agent, so you'll get agent one dash parent one dash
Yeah, yeah. Which
grand,
was the,
right,
yeah,
dot, and then like that's
right.
that'll be that agent, and you can pass that agent around.
So I could WhatsApp that over to Marla
Yeah.
and she would go to it.
Yeah. What
I
I'd
would,
prefer you guys to do though is if you're on the same system, we figure out a way for you to communicate in band, because if the computer is the file system, the computer is also the network card. And so it would be best if you could be like, show me my friends, and it's like, Marla, and then you're like, send her a message asking if,
that would be much preferable.
yeah,
So inside the thread, if I were to say, right, I'm done here. I've got to get to bed. Uh, Send this over to Marla and I ask her to do this. A bit like a text in thread.
something like that, yeah, yeah.
Um,
But it
and
can
that
be
would sort of
arbitrarily
work then, I
complex.
guess.
It's basically intelligent instructions. You like commit this. If it doesn't commit, try figure it out, and but tell Marla either way. But it should all work. And then send it to Marla. Ask her if she wanted it red, blue, or orange, and then go on and publish it if you feel comfortable with it. You can
Right.
do that kind of thing. So it would be, yes, we can make URLs, but the reason why I don't want to is because you are excited about a faulty system. Like the auth needs to be in there somehow. And so
Yeah.
I can attach that and then give you this sharing ability, but that's like several steps down the road. Like I got to get auth on, which will kill that ability to share it around. Then I'd love to get intercomputer communications going, because that's good for all sorts of things. And
Yeah.
then I'll get agentic sharing, where you can permission who is allowed to see this link, and then that's when you can get this feature back, where you start sharing these links by any means necessary, and then you can make it public, private, partially private, conditional, pass a sense check, anything you like. Like you could totally talk your way into the system. You're like, don't let anyone pass unless they sound liberal. And then it can ask them some questions, and then they let you, all the, like you can put it's pretty, it's like, it's not prove you're not a computer. It could be prove you are a computer. Like prove you're an LLM. Okay. So you can, you can do a lot of fun things, right? Because it's agentic. But that's so I think that my priorities now are get auth going. Now that we've got this, I feel like I've reached an agreement with you that your long requested feature of NAP to NAP communication was just demonstrated. Is that correct?
Correct.
So it's now safe to bake down a few more of the specifics, such as authentication, right?
Yeah, and let me be as specific as I can about the base that would be wonderful and I can do a lot of work with. um, is to go to a location with a URL, and then I have an agent with a thread. That thread can throw out other agents that I can get doing parallelized work on some common file system. I'm very happy with the buffer thing. It's like, unless I tell it to save it to it. In fact, that's definitely the way to go, because you want to be able to play around in a sandbox and mess around with it. And then it's going, yeah, that last one, but two that you said, save that one. And then if that is off, so that I can then either in band, ideally in band, but even just text Marla is saying, the URL, go into it and you'll see what's been done. Ideally in band, because that then has the benefit of it being AI. So say, look, send this over to Marla and explain, give a summary of what I've done over the last hour, give an explanation, and here's what I want her to do. And then I can go over to her and it will explain it because it knows about the thread. Then on the agent stroke faces, which we've kind of melded together now. So I would spin up a number of faces to do parallel work, and then I could drop into each face and then talk to that face and go, okay, so this is a subtask. Right, I'm going to help you out with this one. Blah, 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 blah. I'm going to help you out with this next one. And then on each face, I can say, right, happy with that. Save that to the NFS.
Okay.
And then ultimately it's like, yeah, I'm happy with this multiple face work that I've been doing. Commit. And then it goes up.
Okay. Or it could have been that you've been doing commits in branches, but now you're like, I'm ready to make a commit back to main.
Yeah.
Because I've done all my play and I've done all these things, right?
Yeah.
I think that this system does that.
Yeah, I think it's auth is necessary. Of course. I like the NFS thing.
NFS saves us a lot of shit. Okay, so let me try. I need to rename some things with you then.
Okay.
Agent becomes what was that default face, which was the face that you land on. Like that's like this face. Like when I first
flashing cursor. Yeah.
Right, the blinking, flashing. This was this thing, right? When I first landed here, I was like, this is Codex. This is face 0. Face 1. But what I want to rename that to is this is the agent. And then the faces are like, this is just one of the faces of the agent. This is the default interactive face of the agent. It may not have one. The face 0 was the system face, which is just so faces become views at this point. That's what I want to change to. So the agent is what used to be the face, but it's the AI based thing, and it can call on other pieces of logic, like firing up a UI in a web, serving a web page, all that. But it's not. You're not talking to the face is just it's just a view.
Mm-hmm.
So the container that runs the agent is a Coco, and the Coco is the Docker container with the kernel and the file system, and will eventually be wrapped in the confidential layer.
Yep.
But it's one Coco, one agent, and that agent is what's specified in that agent package.toml. But I'll rename what that.
Isn't it? Sorry to rewind. Isn't it one agent per Coco?
Isn't that what it said?
No, you said one Coco per agent.
What's the difference between those two things?
Coco can run a number of agents.
If I said one, there's one agent per Coco. Doesn't that imply that there's one?
Is it 1-to-1 or?
Yeah. Yeah, okay. That's the refactoring and concepts that I'm asking for.
Yeah. Okay. All right. Yeah. Okay.
So when you talk about an agent, what you really under the hood mean is there's one Coco. There's this.
Right. Sorry, my bad. Yeah, because it's a container.
Yeah. One container.
Yeah, I was thinking at a computer level, at tin level. Yeah. Okay.
Right. And then this agent is what was this sort of base face, but it's the AI capable thing. And then on it can also be multiple faces, which are just the views of different things. Like,
right, yeah, because that would the views in that case would be your personal preference. Maybe you want it in graphics, maybe you want it in audio.
Yeah, that's right. It can be any number of things. And like, look, maybe faces still has a place in terms of like, okay, this face can take serial communications, this face can take UDP data packets, this face is a fucking weather vane out in the, like, it's just some kind of data in, data out system.
Yeah, it's
an interface, I suppose, is probably the more common term.
It's like a socket on a server, really.
Yeah. The interface. There's an interface of some description, but I'll try to rework that naming. It might be I got to rename face and all that and just call it interface. But so long as we've got this concept of the agent is what used to be the AI face, and that's the AI thing.
Yeah, and that works because you've got the malleable NFS and commit, and so you can interact.
Yeah,
with others.
Yeah. Because I originally faces were supposed to be so that you could run multiple processes that are like a web server or something, so that people could see it in different ways. You could just present it as different ways, and then because of the constraints in the system, it became, well, now I want to run multiple codecs agents because I don't want to have to fire up another container, and I need to work on the same file system. But you're right, I forgot that what it should be is NFS, and then it doesn't matter, and it's one Coco per agent. That's it. Scales infinitely without any kind of resource management. So long as the Coco running the agent is specified correctly for the resources it needs, that's all you got to worry about. There's nothing dynamic about the resource usage that's going to come and require a sysadmin or some other kind of decision.
Yeah, because you just Yeah,
and I love that. It's like
you never hit
cheap, infinite, like mentally cheap, infinite scale, with really not that bad wastage. Because if the Cocos can be like halted and deep persisted in the NFS layer, then how much resource did they really take? Like, they only cost you resource when they fire up and do something. If they're just hibernating, then they're just
Yeah, you could stick them on tape if you wanted.
Okay, well that's so I should not refactor for stability or modularity just yet. I should get auth in. I should get the agent config file sorted so that you can modify sysprompts. And I should get multi-agent going so that you can easily spin up new containers and stuff.
How does your entry agent face 0 call out, and where does it call out additional agent stock faces? Where
How does it create them?
Yeah, where does it say if I altered the JSON from the template?
Yeah.
With additional prompting.
Yeah.
How does face 0, agent 0, know about those, and how does it spin them up?
All right. So with the NFS, which solves a bit of a problem there. So in the NFS of the computer, there would be a folder that was like agents, and in there would be a list of these agent.toml files that contain all the configuration required for setting up an agent, as well as having different like markdown files in a folder. Like you might have a folder called sysprompts, and then the agent tomls just refer to the sysprompt file as that's where the sysprompt prompt. But so details. Basically a folder on the NFS that has a list of agent config files. And then when you want to boot one, you say to whichever agent you're talking to, whichever one's alive, you're like, "Oi, go to that folder, pull up the catfish.toml agent file and boot it."
Right.
And then you talk to it and you're like, "I want you to generate me a sexy profile picture. I'm about to go catfishing." And then off that agent goes.
Got it.
And that now that I get to say that to you, not the catfish, but the NFS and config file, this is way simpler than the shit I had in my head this afternoon. So, but ditching that like multiple faces on the same agent thing, being capable of doing AI calculations, that simplifies down the agent.toml file to be like, is what the complexity of one face is now. That's all the agent.toml file is. It's very simple.
Yeah.
And then being able to specify which one you want is easy, and there's no resource management problems. It's like, well, this is how that works. And it's the NFS, I think, that simplifies a lot of stuff there, because you need this like stable place to store what the config files are, and you need to be able to point at it to load it, and
and the so the NFS is persistent,
eternally
GitHub,
persistent.
Yeah, the GitHub is the work that you're working on.
Well, GitHub is really at the moment, once the NFS goes online, that'll just be a backup or a way to sort of exfiltrate your data, but the NFS should be the place where the Git commits actually happen, and then you'd sync with GitHub. The only reason why we started this conversation talking about GitHub as a workflow is because without NFS, you need to rally around GitHub. So you got to like push and pull from GitHub because we didn't have NFS. But with NFS, you commit and read and write and do Gitty stuff on NFS, and then when you're ready, you push and pull to GitHub, but it's less important now.
Yeah, and the only reason you push and pull is if you want to do something outbound, like I got a shit ton of files that it would be easier just to do direct outbound.
Yeah, or something like that, right?
NFS. Yeah, that works.
So that seems pretty easy, actually. Okay. Now that we talk through it. But then what? Like, even okay, I'll give you all that. Is that enough? Like, are we at a point?
Enough. I mean, there's plenty more to make it pleasant, right?
Right. But what my fear is that something we want that makes it more pleasant changes fundamentally how we've laid out some of these things. That's what I'm really afraid of.
Well, the only thing we've not talked about is calling out to other NCP servers. Or I kind of promise, you know,
that's
you know,
easy. Calling out to a
is,
remote MCP server.
yeah.
Yeah, that's easy. That's not a problem at all. That's just the same as browsing a web page or pushing and pulling to GitHub. That's just a network call.
Right. Okay. So we can call out to anything that exists now.
The whole internet is ours. Yep.
With views, we can, make it pretty. No,
With views, we can present any kind of web-based interface that anyone could want, including a direct terminal shell into the backing server.
Right. And so you could display jitters.
Display jitters. Tell me more about that.
So if I on one of the previous commands was like, what's the weather in Edinburgh? Show me the weather map, radar map from the Met Office.
Yeah. So you could definitely do that, and more to the point, what you would do is install the extension in your browser that would allow the computer, the agentic computer, to position your tabs based on your commands. So when you're like, hey, show me I want you to code for me a ASCII-based weather map of the current rain forecast in Scotland. And then it would whir away in the background, and then it would open a new page that would be pointed at one of the views that had fired up on the agent, which served the page that it just built, tested, and ran. And then it would resize your window so that looked like the state board flying in, taking up 2/3 of the screen real estate and squishing your chat box down to 1/3. And it's like, what do you think?
Right, gotcha. So jitters are included in this, so you could ask anything like that.
That's a good point. So the concept of a jitter has changed because, oh man, fuck. What is a jitter in the world of agentic? What is an agentic app? Because that's not quite... Agentic and jitters are not... They seem different, hey?
They do a bit. Essentially what you want is display, but then you may also want to interact with that display.
Yeah, so... I mean... I guess the jitters are the web pages, the views that it shows. So it renders it as a dedicated page, and then you just load it and view it in your browser, and you're like, this page was made just in time.
I think so, but if you take something like Street View and you want to pull the wee man over, are you interacting just with the newly built webpage, or are you interacting with the agent?
You're interacting with the view that the agent has presented you. So you would look like this. That would pop. Just go away. Don't share the God damn that. I've gotten away with so much without having a major faux pas there. But anyway, so this is the Navy base where I frequent. And so this would be me interacting with a jitter. It could show me Google Maps directly, sure, but it could also make its own dedicated view that included the the library to show this on screen, and it's able to extract out like the points I click. So when I do something, that's interacting in a way that then the agent can interpret. So
Right,
you're not
so
you're
I could
interacting
then,
with the agent via a view.
so I could click on that vessel there and say, hey, what kind of vessel is L421? What is that?
Right, but that could be another sort of a just-in-time thing, because you could leave it here and then go, what the fuck is this? It knows what you're looking at, but it knows that, like, how would you expect it really to do that? So at best, what it's going to do is it's got the GPS location you're looking at. It then grabs a screenshot, and then it starts sending out agents to do background research. It's like, what's at that point? What's that thing? What can you see in this image? Find all the text. What type of ship is this? Where the fuck
Yeah.
are we? What date was this taken? And then it whirs away, and then it might sort of present you a new page, which is a image of L421. And then it's like, it'd pull up a new page with an image, and it's like, hey, I think this one's sunk, actually. Someone drove it into the fucking reef.
Really?
Yeah, whatever.
Shouldn't do that.
No, well, that's what the whole country thought, actually.
Well, I think I heard about that.
Right?
No,
They were
there's
off in Samoa surveying the reef, and then they hit the reef. I'm like, dude, it's like
yeah,
you're
and
out
they know
train
where the reef-
spotting and you get hit by the train. It's like you were you were looking at the train. That was your job, and then it somehow got the like.
Yeah, I think I remember that because I follow a YouTube channel about shipping. Just kind of a bit of a shipping nerd. And,
Ships and giggles.
Yeah, there was it wasn't as straightforward fuck up as it sounds.
Well, they never are, but they ultimately arrive at the same place. It's like, we gave you a boat, and you came back without the boat. And
you go find this reef. Found it. Yeah, we're now actually
yeah,
on top of
it's
it.
like we have mapped it with our bow. It's good news and bad news. Good news is New Zealand has a submarine.
Yeah, I remember.
Yeah, so that's how that would go, right? And then the agent would start presenting you jitters that it either pulled in from a library, where it's like, if you want to present an image, use this thing. If you want to present a map, use this thing. So it's got these pre-built things, but it can also do its own coding and make something for you specific to purpose, depending on its time budget and how likely it thinks it will be to reuse it.
Yeah, because it wouldn't be too much just to even create HTML and display everything you know about Canterbury.
Yeah, that's right. Yeah, right. Even just a simple little nice pretty little poster version with like, here's the reef, here's the ship, under the ocean.
Yeah, and here's the court martial.
Yeah, and then there's like this collage of things, and then it could even give like basically you could go to town, and I think that's jitters.
Yeah.
Right.
Okay.
But it's much freer and simpler for us now, because the real thing that did my head in with jitters was how to present them in the browser on the fly, and then know which one you're showing, and then it, like that started to just crumble in my hands and just fucking explode with smoke everywhere. But now we're like, this is the state board. It's called your computer screen, and we can do anything we like in it.
Yeah.
And suddenly it's no problem. Nothing's a problem.
Yeah, that's nice. That hits the mark. Okay. Let me think. No, I have no further questions.
What? Okay. I might.
Okay.
face talking to face did not make. That's good. And I'm gonna put agent.toml in a folder in NFS. Okay, and then auth stuff, auth NFS multi-agent, right?
Yeah.
Auth NFS multi-agent. And I had a thing called topics for chat. We have covered that. Agents is all about faces. So this was my thing, right? This was my list of things to do, but actually what you're saying is fuck off. But actually auth NFS, which wasn't even getting a mention until right now, multi-agent.
Yep. Yeah. And then in due course, in-band messaging, where the
what's in-band messaging?
Agent Zero is aware of RBACs, so I can say, right, I'm done for the day, send this over to Marla.
Yeah, okay. In-band, so you want computer-to-computer communication.
Yeah. So
now, I've got a funny idea that's actually going to be bloody easy. As you've seen, the whole internet is right there for us in this model. Like, we can already search it agentically, pull from GitHub, browse it, present pages that exist on it, be browsed to by others. Like, it's like, this is freedom. Like, it's like, this is the internet computer. We are sitting here unrestricted with the ability to do anything we want. Like, it's feeling pretty good, but it's feeling like a, don't know if you've ever been like tobogganing or snow sledding, but it doesn't take a lot of friction to really kill your slide. And then you sort of fix it and you figure it out or clear it up, and then suddenly you're like, oh shit, we're off. And then new problems come. But it just feels like we keep hitting rocky bits.
Yeah. What else did we talk about? Well, as part of auth is the host names generating parent.
That is multi-agent.
Right.
Because it's no point having agents if you can't communicate with them.
Yeah.
I was bothered about the amount of fly specific stuff. Like fly.io imposes a little bit of specifics on us, but I think maybe I'll just fucking get over it because it works. It works right now.
That sounds like we can wait for that.
Yeah. Some of this, there's a lot of bash scripting going on. I'll think about how to reduce it down, but I'm also I don't have good testing in place for agent-to-agent communication because it all at the moment goes through, you got to make a genuine AI request, which makes it hard to actually test it because it's all different. So if I put in a bit of effort, like a day or two, I can get a way to mock that in a test environment. But the gamble or the trade-off is I think I can just limp along. I mean, I just showed you it working. It's kind of, under the hood, it's not that complicated, but testing it's hard because it's infrastructure. Like, it's actual TCP ports, listening ports, standard IO, DNS, changing the DNS because you decided to rearrange what folder your agent was in the folder hierarchy. Now it needs to know that it changed. It might have been in a folder with 1,000 agents. They all need to know. That's a problem. Like, it's all these kinds of
but we're still in friends and family kind of
friends and complete strangers on the internet. So is it correct then that my general theory should be don't just limp along, don't stress about fixing up all the bash scripting and the bits and the ugly bits that are here and there, and just focus on getting some of these bigger bits up like auth, NFS, multi-agent, and then try and push through with just enough, like just keep it shitty, keep it Band-Aid.
Yeah, precisely.
Yeah.
Because then I can get my teeth into some of the prompting stuff.
Right. So the goal is get you online, right?
Yeah. Yeah.
Okay. Get you online. It'll be shitty. It'll be rugged. And then, but at least you'll have the tool, and then we can start working together, right?
Right. Yep. Yep.
Okay. Okay, that's it for the platform update. Let's call that. I got a bunch of other stuff to go through on Coco. I'm okay to wait if you need to get going.
Let me double check. Wait a sec. I believe I'm good. Let me check. I'm good for half an hour.
Excellent. I hope that this doesn't get us banned. Anyway, this is a whole song about Coco, and that's all I've been listening to lately, about a guy who's in love with the Coco. With Coco, there continues to be very surprising benefits and things that come from it. So the one I've been toying with lately. Okay, we need to be able to make a service. We need to be able to make a service that stores the keys. Like there needs to be this sort of there needs to be some Cocos that never turn off. Those are the ones that everyone comes to when they want to turn their Cocos on, but they didn't want to pay the bills of keeping them all up. And that is the one that has the fancy engineering bits like consensus and, you know, what's the latest commit of the Git repo according to the Coco consensus. Like that's actually what the chain value, that's what the crux of it, because it's like a core cluster that anyone can go to know, to be able to, first of all, gain access to the private resources of their Coco by way of being given a key to unencrypt their data, so that in the Coco pool, you can fire up your container past the attestation that says like, yep, AMD says this is all good. Request the key management service and be like, oi, you know, what's the latest block and where my key's at? And then it's like, yes, I see that you've booted correctly. AMD says you're okay. Here's the keys to decrypt your data, and this is what the latest block hash is. Go. That bit is actually, it's not, I wouldn't say hard is the right word. It's cumbersome. It's complex. And if you offer it as a bundled service, everyone else can leverage it. Like once you have that bit, everything else is easy. And so that's the rallying point of the blockchain, is like that core service, the key management service, and what's the latest Git hash for whatever repos you want. It's effectively like not so much time, but order. It's order keeping and secret keeping. And then from that, it's pretty easy to make additional services that leverage that, like a time service that's for Cocos, like a Coco time server, a Coco DNS server, Coco exit node, so you can browse the web, all those features. But it all hinges on having that top level key management system.
Okay.
So, Coco is 100% like the way to go for us, the future of computing as a whole. But I wanted to ask you, based on the SEC's definition of decentralized, if you had even just a small Coco pool of, like, say, 100 different diverse operators around the world, people running systems, could you, given that you can make a Coco that can run in that pool and answer to nobody, like you can purposely make it fire up and you'll be like, email the president this one message every day for a year, and the only way you could stop it is to stop the Coco pool. Would that be considered autonomous from the point of view of decentralized income?
Decentralized, I think one aspect of it is, can any one party, destroy it, switch it off?
Right.
You control something if you can destroy something.
Right. So that means you can't turn it off.
Yeah. So if it's out of the control of someone, as in no one party can fuck with it.
Yeah.
Then it is decentralized.
Does the fact that the Coco can be set up and run following rules that cannot be changed by anyone reduce the number of diverse political parties that are required to run the Coco? Like, before, for a blockchain, I thought you needed, like, I don't know what the number is, but it's probably a lot, because you can have software flaws, you can have hacks, you can have diversity issues where people are running the same version of software. All that doesn't really matter in Coco, because it's like, well, AMD could change it, but AMD's disinterested. The only other thing,
AMD is not a party in this sense of control, because once it sold you the chip, they sold you the chip.
Yeah, so sure. I guess what I'm poking at is that it might be that decentralized income is not just closer with Coco, but it might be like the same day. It might be same day as Coco. As soon as the CocoNet goes live, it might be that we have decentralized income.
I don't follow why that would follow.
Because you can't, to be a decentralized chain, we could pass the tests of decentralized with Coco with far fewer participants, and the security guarantees would be much higher.
Yes, on the second. I wonder what it... Decentralized. I mean, what point does decentralized kick in? It's definitely not one person.
It can't be one. It can't be two. It can't be four.
Yeah.
But there's going to be some amount, right? And like, it would even be worth it for us to buy, like, you can buy one of these, you could buy a Coco capable box for about $1,500. Like,
yeah,
if you bought, say, so 10 of them would be 15 grand. If you bought like, I don't know, 40 of them and then sent them out to people.
Yeah, but the whole point of decentralized is sure, you got your 51% problem, but it's no one person can mess with it. So whether it's 10, whether it's 5, if they were completely independent, then that would be decentralized. It's to do with control. Decentralized is all about the
right, and
ability to
deception, or
control.
the ability to deceive.
Yeah. So even though 51% attack could make a chain non-decentralized, it is unlikely that anyone's going to get to 51%, and so it's not impossible. And so it's a matter of degree, isn't it? And I wonder if there is a definition, SEC definition of decentralized.
There is. I'll look into it to see how it fits with Coco. But so one example is that we could start up a Coco that its sole purpose was to crawl the internet looking for good deals on Coco capable computers, and then it would acquire them, provision them, put them in the pool, earn money, and then pay back its investors. And so at what point is that decentralized? If the Coco runs in a way that no one can change it, alter it, whatever. Because what I realized was that you can boot a Coco in such a way that it generates an Ethereum private key and then it never lets it out. And so it can publish its public key and you're like, here's $100. See what you can do with it. And then it can be programmed to never ever release that key. But now it can sign transactions on the Ethereum chain, which is a really damn hard thing to do. Bridging between currencies in a decentralized way is a nightmare. But with Coco, you're like, well, the Coco runs in this decentralized fashion. It has the keys to control an Ethereum wallet, and it's safe to do so. Like, that's really the magic point I'm trying to drive at here. To be decentralized and keep a secret is a nightmare. Because in the traditional sense, it doesn't work, because if you've got any participants, they all see it, and how do you know which one leaked?
Mm-hmm.
And so controlling a wallet on Ethereum was really, really hard to do. But with a Coco, it becomes really trivial. You like generate the key, don't let the key out, do the stuff, and that's it.
So there's no central control there.
No.
But you touched on something about, well, what happens when you need to update that because stuff's moved on.
Update what?
The key controller.
You mean that yeah. So how do updates roll out for the key controller?
Yeah.
I think that we could make a version that ran OSS 120B that could decide when it was time to do an upgrade or not.
That's where I was leading with that one, because key control is a pretty standard thing. The AI is not going to get confused about key control.
It kind of doesn't care, right? All you're asking is like, well, is it better than this thing or that thing? And when I ran you 100 times, did you give me the same consistent answer?
Right.
Like,
right.
It doesn't really care.
So it's a bit like an autonomous Coco.
the top level chains need to be autonomous, because otherwise somebody will be under pressure or temptation to make modifications to the system.
Right, right. Or they may be malicious and so on. But if
Yeah,
it's actually out of your hands
yeah.
and the AI is deciding, it's like, good luck with that. You've got
Mm.
um, the same
So if we
vector
launch,
in as everything
if we
else.
launch in a safety mode, where it's like, for starters, we will hold the keys. We'll call it command, and
Yeah.
we won't, like, it'll just be like a shared key system, and that's basically the safety switch while we're ironing the bugs out. And then you launch the primary key controller
Mhm.
and watch it, and then at some point you hand over autonomous control to it, because you're like, well, it's passed all its tests, it's run stable enough. Here's the
Yeah.
here's the
Yeah.
keys, right? And then you meet also one of the SEC's guidelines is it's got to be running for more than a year. So if we can,
That sounds
you know,
arbitrary. Why do they do that?
just to make some sense of stability, I guess. But if we can, like, start it and then have it run and get the clock ticking, then we can start allowing it to print internal money, where it's like, here's the trading mechanism. We know what the unit of value is. The unit of value is cocoa, and this is how you trade to, attain it.
Well, yeah.
Right, and cocoa can be quite expensive, particularly like if you want to run cocoa GPU. It's up there. It's up there in terms of price. So, not because of that's just because GPU in general. That's not anything to do with cocoa. So, I think what I'm getting at is that there's some famously hard problems, like controlling an Ethereum wallet key in a decentralized fashion, that become trivial.
Yes, because the trust has been moved onto AMD.
Yeah, which I don't know if we should be worried about that, but I'm just saying that if we do that, so many things get really, really easy. And so I guess what I'm really fucking itching about is, I'm like, man, I just want to get on and build the Cocoa network, but I gotta get you online first with the agents, so that together we can start collaborating using these agents to get all these other tools going, solve all these other problems. Because hitting Cocoa without agents will be a lot more work than it needs to be.
Yeah, for sure.
But this feels like Cocoa's that's the thing that we should be trying to build with the agentic system.
I agree with
Is
that.
it wrong?
No, I agree. I entirely agree.
So at the moment, then, you could say that our mode was prototyping the agentic computing model using NFS and multi-agent and agent.toml config files to try and just feel our way around and be like, yep, that's good. It feels like the future. It feels long lasting. It feels good to use, helpful to use. We can do good work with it. And then we're like, all right, we're going to do some base stuff, which is like clean up the mess we've made over the last 6 years, get some recurring revenue going, whatever. And then we're going to be like, right, we're going to hit CocoaNet. And then we launch CocoaNet, flick the operations of our agentic computers into Cocoa, and start trading Cocoa resources using an intrinsic currency. And then we just carry on doing all the work that we can see, the utility, but we now have this self-sovereign capable system that can also integrate with some very difficult to integrate things like Ethereum in a trustless way. So a decentralized, treating it like a payment rail. Basically, there's no feature we don't have at that point
Yeah.
and it's
Yeah.
easy. Like
And that
we
was,
can use. I will shut up after this statement.
you know,
We can use the agents to make the Cocoa agents, like the Cocoa components, like DNS, the main chain, all those things. Like you should be able to very trivially easy vibe code a Cocoa agent using the Cocoa agent system, and when it vibe codes those things, it should be like part of its normal operation of solving a problem for you is to go out and vibe code a Cocoa agent, test it, run it, blow it up, try it, iterate on it again, and that's just how the system works. Like,
yeah.
yeah.
Yeah. I agree.
Sorry, you were about to say.
No, I was just about to say, the utility of that is exactly the same bootstrapping level that you were just talking about. Once we get the agents and the NFS, etc., up, none of that needs Cocoa.
No.
It just Cocoa allows it to be used in the realms of what we're talking to in terms of sovereign states, for example.
Right. And also like DAOs.
Yeah.
Blockchains, autonomous companies.
Yeah.
Okay, so one last fun question. Are you okay talking about Murdex on stream?
Mudex?
Murdex.
Oh, Murdex. Yeah, sure. So long as, for the record, for the tape, this is entirely just a thought experiment. But yeah, go for it.
All right. Well, we don't actually have to say what it is, but we can talk about the mechanics of it. So, Murdex in a Cocoa environment.
Yeah.
Highly private brokered deals between parties that are estimated to be mutually interested, shall we say. The Cocoa contains all the information about who talked to what, who's going to be where. The Cocoa can run an AI model to optimize the plan for each end of the deal. And the Cocoa can be used to coordinate with other participants who don't even know each other. It's just that the Cocoa system is coordinating these people towards achieving a plan, but no one knows what the plan is overall except for the Cocoa. And if the programming is done right, no one ever will. And so all these seemingly independent events happened following no known coordination plan. So the awareness wasn't there. Everyone thinks they're doing either repaying a favor or they got paid $100 to move this thing here or block this piece of traffic at this point. And it's all been worked towards this autonomous intelligence's live monitored running plan to do something that may be frowned upon, but the Cocoa would self-destruct at the end.
Yeah, that makes sense.
And if you can do that, what can't you do?
So the point being there, you don't have to trust the other person.
Or any of the other people. You also don't have to even know what the AI's plan is, which is a little scary.
Yeah, so it's like, go here and drop this package off.
Yeah.
For example.
Or, send money to this account. Okay.
Yeah. And when challenged, you go, well, yeah, I got paid $10 to do this thing. Drop it off.
Yep.
Why? Oh, because
needed $10.
$10. And it's like,
because
$10.
$10.
That. Oh, this AI and this Cocoa. Where is it? It's not there anymore.
Shit. And then, like, if you set up an agentic system with some pretty nefarious goals, and it couldn't be turned off, and it couldn't be found, and it might not, you could never look inside it unless you had cooperation from A and B.
It doesn't even need to destroy itself, does it?
Well, that was the problem that we always had with running that kind of system with our old view of how blockchains should be. Because you could always inspect what the blockchain was doing at some point. And so at some point you can imagine that someone's motherboard gets tapped. There's like a fucking, a wire trace on the RAM put in, and now suddenly people know what the agent's going to do next, right? But in Coco,
it's
it sounds like
you'd have to satisfy yourself that the Coco that was giving you the instructions was a fair agent. That's all you'd have to do.
Right. Yeah, which is easy to do because the thing, it'd be like an email. A secure email comes in, and then you're like, right, agentic team, map out what you think the Coco is trying to, this other entity is trying to do, and then work out the pros and cons for me, should I do it or not. And then they work away, and they're like, yep, do it. It's good. Sounds good. Looks good. Yeah. And then you're like, okay, cool. Now, if you deploy that in a battlefield, what kind of fighting force have you got when no one on the battlefield, no human, knows the plan?
That's an interesting one. The danger is in the plan on the battlefield because shit goes, hits the wall pretty quickly, and knowing the plan allows the person there to make their own decisions.
Right, but I don't mean that you're completely blind. Like, you get sort of the next steps in the plan, but you don't need to. You only need to know as much as your sphere of influence covers.
Well, that's right. I mean, the
how can espionage have any benefit to you if the actual plan was hidden from all humans?
Yeah.
And would you find a fighting force willing to work like that?
Command control means you just need to know your intent of your one up, and so
one up, yeah.
You're given was just one up in a hierarchy that's end deep.
Yeah,
you don't need to know.
And then this thought experiment gets super interesting because then you can have multiple fighting forces that don't trust each other, but still have some common goal, being controlled in a way that they can all be confident was done fairly because they've all attested to the Coco operations. They just can't see what the insides of each one is, but they all had a hand in running it. And now they're able to coordinate at a much finer, more cooperative, more constructive level than any human was able to do because they trust that their best interests are being looked after each time.
Yes.
So you could effectively... sorry.
The chance of interception of the entire plan is zero.
Yeah. You could even send your Coco agents could be sent into the planning process, and you agree, you can see that they've been run and run correctly and had an influence on the plan, but you never know what. You just know that you put your sys prompts in there, everyone saw what your sys, like you had your goals and your values input, and you know that it ran fairly, but you don't know what the details were. Like, that's kind of crazy, I think.
Again, it's putting faith in the Coco, isn't it? That's all each agent or each individual person needs to do. Like, do I trust that Coco?
Right.
And that is, you can sort that out for yourself. But if you do trust it, then you can get just enough information to do your job on a larger plan.
Yeah, that starts to feel pretty dangerous, man. Like, that's pretty interesting because it's like we've never had that ability before. And now we're like, you can run an AI and not know what it's thinking and never know what it was thinking. And it's going to manipulate some stuff in the real world based on some goals.
There's some really interesting things. I'd love to run it as a model in, that thing that you showed me a few calls ago, where mate was doing the let's pretend to be drug traffickers kind of
Yeah,
GTA
yeah.
style.
Well, that's the thing. Like, you could genuinely do that for real in Cocos, and
Yeah,
you would probably outperform all other competitors.
probably break the game. Yeah.
Well, yeah, and what's to stop you doing it for real? Anyway, that was the only thing I wanted to really. Oh, one extra technical point with Coco.
Mm.
It is possible to also get host attestation out. So basically, when you boot the confidential VM, you get an assurance signed by AMD effectively that the VM is secure. But you can also chain that proof to have the host's trusted platform module assure you that the host is also
Oh yeah, that follows. Yeah.
secure, and that it booted this particular operating system. Like, this is the hash of the operating system it booted. So you can be running your container and you're like, not that I think it doesn't matter, but it always helps to feel better that you're like, yeah, and the host was not infiltrated either.
Yeah.
And then there's probably a market for selling Cocos that are physically contained as well. So you're like, this guy with this name and this passport number has assured us that the building is secure, and he's running these Cocos with attested hosts, and it is a Coco after all. And I don't think you should have had to worry about all that. But
Yeah. Would you gain that much from that? Because it's signed. The
no,
chip itself.
that's the thing I don't know, right? Is that what people want? We're gonna have to test the market a bit on that one, but I love this Coco model. Like, I love it because it means that we don't have to play price wars over hardware, compute, and energy. It's always going to be the cheapest because there's no person overhead, there's no admin overhead, there's no data center, there's no administration, there's no permits. You can be people can be running these things in their closets, like, you can have, like, my latency to someone down the road in this same city is around about 2 milliseconds, right? Like, I can have, in every city around the world, you can have like 2 millisecond type of latencies, because the Coco network allows you to be dark edge. Means you can go beyond where any data center is. Like, you can be closer to the customer than any data center. You can't beat that. The price is like de minimis, really. It's compared to a data center, it's like you just need this box, the CPU, in fact.
And also, the price point on Cocos, I don't know what the differential is, non-Coco and Coco. Right now,
well, you can't buy AMD chips these days that don't have Coco.
Well, this is it. It's just because the manufacturing process doesn't cost any more.
Nah, like, it's just there. It's like this thing, and then, like, people can run these things in their homes. The electricity is like whatever, the resilience. It's like such a great. It's like, I don't know why we haven't found this stuff before. It's fucking.
Yeah, I agree.
It is wild.
Right. That's
time to go.
Huh?
Yep.
I need to go.
Okie dokie, buddy.
That was a good one.
Didn't run out of storage this time.
Once again, sorry.
I said I didn't run out of storage this time.
Oh, excellent. I think there was a lot of common ground there.
So this was a model I made a long time ago, talking about secure VMs and all that. But I guess I didn't really properly get how to make it all work. You know, like making a blockchain out of trusted silicon.
Mm-hmm.
And then being able to drop, you know, like this was SEV was the AMD thing. I was like, yeah, we can actually. Anyway, whatever. I was sort of in the neighborhood of the concept back in fucking, you know, what, 2021? Because that was when AMD launched that feature. And I was like, hey, that's amazing. But yeah, now we know what to do with it.
Yeah.
4 going on, 5 going on 6 years later. Anyway,
Yeah.
that's that.
Yeah.
I'll stop recording.